Hi guys, let's take a look at this question where we have a hot air balloon that is moving upwards at a constant unknown speed. Constant unknown speed means acceleration is 0. 3.1. Is the hot air balloon in free fall? Choose from yes or no and give a reason for your answer. So the answer is no. Why? Because free fall means that the only thing acting on the balloon is gravitational force. But here, that is not the case, so therefore it is no, because gravitational force is not the only force that's acting on this balloon. There are other forces like acceleration is 0. Acceleration is 0, and it's at a constant velocity, so there are other forces in play here. Okay. When the balloon is 200 meters above the ground, as you can see here on this diagram, a small stone A is dropped from the balloon, as you can see there. Another small stone B is dropped 5 seconds later. So there's another small stone coming along there from the balloon while the balloon is still moving upwards at a constant velocity. So we're going to take up as positive, right? And we're going to take down as negative. Please write that on your as soon as you start the question, so your examiner can know what you're taking as positive and what you're taking as negative, because that will influence a lot of your calculations. And then they tell us that stone A strikes the ground at a speed of 62,68 meters per second. 3.2. Calculate, number 1, the speed of the hot air balloon. All right. So what do we have so far? We have the height above the ground. We have the final velocity, which is right here. We don't have the initial velocity, but we do have acceleration, because remember, acceleration is constant, right? 9.8. So we have things to work with, right? What do they want? They want the speed of the hot air balloon. So they want the initial velocity, because we have already given them the final velocity. They have already given us the final velocity. So let's look at our equation of motion. What do we have? We have final velocity, we have acceleration, and we have the distance. So we can easily use this formula right here. So again, please write down your formulas, because you do get a mark. I know I say this all the time, but please write it down. You could also write y, does not matter. So final velocity has been given. We're taking down as negative. So that means it's going to be negative 62,68 squared. We don't have the initial velocity. Our acceleration is constant, which will be downwards, because gravity is acting downwards, and we're taking downwards as negative, so it must be negative 9.8. And our height is also going to be negative, because it goes down, right? So that is going to be negative 200. And then we do our mathsy calculations. We square it, we multiply it, we take v over, we get the square root to get our initial velocity to be 2,96 meters per second. So that is the speed of the hot air balloon. Calculate the time it takes stone A to strike the ground. All right, so what do we have? We have the final velocity. We now have the initial velocity. We have the acceleration, because that is a constant. So all we need is the time. So that's a quite easy calculation. So we can just use this formula, because we have everything else. So again, please write down the formula, because you do get a mark for it. I know I sound like a tape recorder. Okay, so final velocity has been given, and we're taking, remember, downwards as negative. So it's negative 62,68. If you took downwards as positive, all your down motions will be positive and all your upwards motions will be negative, but I took down as negative, so it's negative. Then our initial velocity will be positive, because that's upwards. So it's 2,96. Gravity is acting downwards, so we're going to have negative 9,8. And we don't have the time. That's the only unknown. We do our mathsy magic, multiply, take it over, divide to get time alone, and that is going to be 6,70 seconds. 3.2.3. Distance between, or calculate the distance between the hot air balloon and stone B at the instant when stone A strikes the ground. So what do we do? So I'm just going to clear the screen. Please keep everything in mind, all your little things that you have to remember, because I'm just going to clear the screen. Okay, so we got to calculate that distance. So what is the first step? All right, so let's check what do we have. So we want to calculate the distance between the hot air balloon and stone B at the instant when stone A strikes the ground. So let's first calculate the distance that stone B travels, right? So let's calculate that first, because why? We have the initial velocity, which we have just calculated. We have the time, which we also have just calculated. Yeah, and we have the constant of acceleration, and we have everything we need besides the distance, right? So let's calculate the distance that B travels first. So let's see which formula we can use. We can use this formula. Easy peasy to just get the distance. All right, I'll write down my formula. You can also write that, doesn't matter. But I want my 1 mark, so I'm going to write down this formula, even if it's so tedious. All right, initial velocity was calculated as positive 2,96. All right, my time, remember, the time it takes stone A to reach the ground was 6,7. All right, 6,7. And when was stone B dropped? Stone B was dropped 5 seconds later from the balloon after stone A was dropped, so we can just minus 5 from that. Remember, gravity is acting down and we're taking down as negative, so it's going to be 9,8. And again, times 6,7 minus 5, and we're just squaring that. We jot that into the calculator and we get the distance that B traveled to be negative 9,3 meters. So we just make that positive, right? And we say down. Then we can calculate as well the distance that the hot air balloon travels. And we can use the exact same formula. And I'm going to rewrite my formula. This just sets the tone for the question, so you know where to insert what. All right. So we have calculated initial velocity again, and the time is going to be exactly the same. But what's the difference here now? The difference here is now that the hot air balloon was moving at a constant velocity even after stone B was dropped. So that means acceleration is still 0. Anything multiplied by 0 will remain 0. So that whole calculation, that whole equation there is 0. We jot that into the calculator and we get the distance that the hot air balloon travels to be 5,03 meters. So now we can calculate the distance between the hot air balloon and stone B at the instant that stone A strikes the ground, right? So that is going to be, so you can just write distance between hot air balloon and B. So I'm just going to write distance. Will then be the 9,13 plus the 5,03, and that is going to be 14,16 meters. That is their distance when A strikes the ground. Not too bad. All right. Last question, 3.3. On the same set of axes, draw a position time graph for both the hot air balloon and stone A from the moment the stone is dropped until it strikes the ground. Use the ground as 0 reference and label your graphs balloon and A. All right. So remember, we took up as positive and we took down as negative. So because we took up as positive in this question, our graph will look like this. So I'm first going to draw my axis and I'm going to label my graph time, seconds, and position in meters. All right. So the balloon went up constantly, right? Remember, ground is 0. So the balloon went up constantly. So I'm just going to take my balloon. It went up constantly, all right? But my stone was dropped from the balloon and it went all the way downwards, right? So it's going to look somewhat like this, all the way downwards. Remember, they don't start from the ground, right? They start from a certain height. So they both must have the same starting point and both the same ending at the same time. So it should look like that. So that will be the balloon. Remember, they asked you to label the graph as balloon and A. So that will be the balloon constantly upwards, and that will be the A starting at the same time, ending at the same time. And tell them you're taking up as positive and down as negative. And that's that. All right, guys. See ya.